thank you so much for agreeing to be part of the next community roundtable. David, Daniel, we are going to get started here. If you want to just give us your background first and kind of tell us where you came to this from, we can go from there.
Yeah, sounds good. Nice to meet everyone virtually. My name's Daniel Schaaff. I'm a lead DevOps engineer with a multi-channel marketing company called Cordial. We send a lot of email, but I come to Kumo, a lot of personal interest too. So it's very cool to see a core piece of software like this be open sourced and building a community around it. And I don't know, big fan of the stuff you all have been doing with it. My personal background, I kind of come from a traditional systems engineer background back in the day. Got into cloud operations and lots of stuff on automating the infrastructure side over the years. I'm relatively new to the email space, which is interesting. I don't have a massive background there, so Kumo's been a fun chance for me to dive in there and start playing around with how to run this software in a way that is scalable, hopefully affordable, and does the job well.
Yeah. And for those who have questions, the chat will be open. You can certainly ask there. As far as Kubernetes, I know you have quite an extensive background there. You want to tell us a bit about that?
Yeah, so I started using Kubernetes, oh gosh, probably around, it's pre-version 1.0. I forget the exact version number, but used that for lots of years. It's kind of painful at first, and it's really smoothed out a lot over time. But my particular background, I work with AWS a lot, and I started out doing stuff with ECS years and years and years ago, and the original V1 of Rancher before that. But Kubernetes was nice, just the way the APIs are laid out in the declarative manner you can go apply manifests and have controllers manage the lifecycle of your objects. Really clicked for myself and a lot of other people. So we really leaned into that over the years. And today it's great because you have such a big third-party ecosystem of tooling. You don't have to reinvent the wheel. A lot of stuff is there for you to take advantage of. There's some really nice primitives with scaling, especially in AWS, using the Carpenter autoscaler. So you can really do a lot with taking advantage of spot instances, for example, there, and still keeping things reliable. Great way to save on money there. And then just the developer experience is really nice. So if I want to go spin up a workload, super straightforward to do that, just applying a manifest. Kind of compare that to what it would take with traditional VMs and writing a bunch of Terraform or Ansible to go spin something up and configure an OS and do all that. So Kubernetes has some nice abstractions for making that a lot easier. And then applying that to Kumo, so my interest in running Kumo on Kubernetes, I know depending on where you are with how you run your infrastructure, you might wonder, well, why would I want to do that on Kubernetes? So I think the number one thing is if you're already running workloads there, then it makes sense to stick to the platform you know and you use. So that's why my immediate thought was, oh, let me go run this on Kubernetes like everything else. And there's some unique parts of running MTA stuff that make that a challenge, especially around IP address management and things like that. But I've actually found it's a really, really good fit for the core MTA layer. And I've been pretty happy with how easy it was to actually get that up and running too. Like I know Kumo wasn't designed with Kubernetes in mind per se, but it fits in really nicely with the primitives there.
I would say it actually was. I mean, for those who haven't heard me say it a million times, Kumo is Japanese for cloud. And philosophically, one of the things we looked at that we wanted to change from our days at our previous employer was that people would ask how to deploy their MTA in the cloud, and the answer was use our SaaS product. And we didn't want that to be the answer. And so getting it, I mean, we were building containers right off the early stages. We've been adding these functionalities to even better support it. But yeah, we were definitely going down that road originally. And for folks, when I said the chat, actually, if you use the activity button, which is triangle, square, circle, and go to Q&A, you can ask questions in there, or just ask them in the Discord. Anyway, yeah, so if you want to walk us through kind of how that came together and what you've experienced.
Yeah, so one of the big things I remember when I started looking at this is you hear everybody talk about DNS, and when I'm looking around running an MTA and doing some research online, well, what does this look like? What problems do people have? And DNS keeps coming up. So everybody seems to have problems with the DNS request load, lots of issues there. And so Kubernetes also immediately ticked the box for me there because it has some really good components for running that. So you have core DNS, which is your DNS process for the cluster, but you also have the node local DNS cache, which I would highly recommend running on any Kubernetes cluster, which is basically, it's a daemon set, runs on every single node. All of your pods DNS requests hit the local node where requests are cached. And if they don't have the specific record you're looking for, then that'll get forwarded to the main DNS server. So this provides a similar role to if you're running DNS mask locally on like a raw VM to do your DNS stuff there. And it also has some really nice stuff allowing you to control like prefetching, for example. So you can prefetch DNS records that are about to expire into the cache and do lots of things to keep that low. The other piece is scaling things out. So in my experience with running stuff on Kubernetes, it is a really good way to auto scale things up and down. So I use Prometheus really heavily for this, and you can use the horizontal pod autoscaler with a metrics adapter, or you can use the Keda project, which I'm preferring these days. But it's beyond, like, if you think of your traditional, oh, my CPU is high, I'm going to scale, or my memory is high, the things that you get out of the box with like a cloud provider, you can go way beyond that. So you can scale on the metrics that actually matter for your workload, as far as whatever that may be. So it was a really good fit there. And then standing it up, the architecture is actually pretty simple. I did throw up a sample project on GitHub with how I chose to set this up on Kubernetes. I shared that in the Discord if anyone wants to take a look. Basically, I've got a couple layers to things running there. So you've got what I'll call the MTA layer, which is the main KumoMTA process running and stuff. So this we're running as a stateful set. And the reason behind that is we're going to attach persistent volumes to all of those for the spool directory. So if you have a pod shut down and come back up, that storage is persistent. You're not going to lose anything on the disk there. And that's portable between nodes as well, which is another nice thing. So you can have a pod shut down, have a node go away, and it will start up on another one, and it'll get that exact same volume with its storage bound there. It also makes it easy to expose over HTTP using Kubernetes ingress. So for how I would personally run this, I'd be doing HTTP-based injection. So it's really easy to spin that up, manage TLS with Cert Manager. There's a lot of nice stuff there. And then you have the traffic shaping automation deployment. So this I'm also running as a stateful set, but for slightly different reasons. So stateful sets give you a stable network identity. So if you run a normal deployment on Kubernetes and you look at your pod names, it's going to be a random ID at the end of that you can't predict. And because Kumo needs to have a stable list so it can talk to all of the traffic shapers for when it's publishing updates, you need a consistent thing for it to talk to there. So by using a stateful set, the DNS host name never changes, even when those pods shut down and start back up. So that's why we chose that there. So that way it can send all of its updates. Works really nicely. And then we have Redis for doing locking and not locking, throttling globally. So you can share your throttle state between however many replicas of Kumo you're running. There's a lot of ways you could run that. Like when I was first looking at this, I was using just a single container Redis with the Redis cell module. I know Kumo now no longer requires Redis cell. It can function without that, which opens up a lot of opportunities. In the end, I ended up using Dragonfly DB, which is just a Redis compatible API. It's a little easier to run on Kubernetes, and it has the throttling command that Kumo relies on built in, which in theory should perform a little better than the Lua implementation it falls back to if it's not there. And that's kind of the core Kubernetes piece there. The component that I don't do in Kubernetes is the outbound proxy layer. So I'm using the SOCKS 5 proxy that Kumo ships with. That doesn't really make sense to run in Kubernetes today. Unfortunately, there's not a good way to handle managing the IP addresses and mapping everything there. So that I'm running outside of the Kubernetes world, but everything else is a pretty straightforward setup there.
Yeah, and your proxy layer is the kind of thing that, I mean, you're scaling up and down in most cases for volume, and your proxies have to exist no matter what, essentially, to keep the IPs mounted. So yeah, there's not really an up-down motion to those nodes in the first place. So I guess that makes a certain amount of sense. We have, you should be able to share a screen if you want to kind of walk us through what you've got in GitHub.
Yeah. As soon as I find the button in Google Meet.
Next to the smiley face. Assuming you have the button. Which you should. Gosh. I love technology.
Hold on, I got a macOS privacy prompt for Firefox. Bear with me.
Safe and secure.
Hopefully I don't have to click and drop. Let's see. Okay. Okay. Can you see that?
Yep.
Okay, awesome. So this includes a Helm chart.
Actually, give me just a second. What you're sharing is a window that says you are sharing your screen.
This is why I'm hoping I don't have to quit and reopen Firefox. I had to give it a permission to record the screen. Let's try this one more time.
It did share something, though, so that's good news. Now it's warning us that now it's showing us a window that you are sharing your entire screen. But not actually sharing the entire screen in the process, so. You know what? Give me a moment. Let's do this instead.
I might need to drop and rejoin.
You know what? How about we do this instead? Well, give me a moment. I'm going to share my copy of it, and see if we can do that instead. I'm going to put that there. I'm going to share, and there's not that many clicks to be done, so it's pretty straightforward for me to show it. Let's try this. There we go.
Awesome. Yay for technology. Always works except when it doesn't.
Yep.
Cool. So this repo, we've got a Helm chart in it for deploying Kumo using the components I just talked about. So you've got the stateful set for KumoD. You have the stateful set for the traffic shaping automation, and then it adds the Dragonfly to provide the Redis layer for between those. The actual configuration it uses is pretty simple at the moment. So it'll basically let you inject messages with HTTP, and then it'll forward those through to a separate Kumo deployment that's just running a sync config, or it'll accept the message and immediately drop it. But it lets you play with the components, it lets you see the API for injecting messages. You can also use the Kumo CLI from inside one of the containers to play around with, including generation and things like that. If you want to run this locally, it's not super difficult. The main things you're going to need is a local Kubernetes cluster, the Helm CLI, and then I'm using a tool called Tilt, which might not be as familiar to some folks, but similar to Docker Compose. It's a way to kind of orchestrate local dev stuff with Kubernetes. It was actually acquired by Docker, so now it's part of their portfolio. But you basically run one command, tilt up, and it will deploy all of these components. Then it gives you a UI with the log output and links to port forwarding and things like that. So this is a straightforward way if you want to just throw this up on a local machine and be like, hey, how does this thing get up and running? If you're doing this in the real world, you obviously need to put a lot more time into configuration files and how you're managing those things. But this is a good kind of hello world demo piece. And then it's got a nice little 2 stars. I love it.
So
I
guess one question I'd have with your use of this, how are you handling load balancing on these nodes?
So this local example just does port forwarding, but when I run this in a real cluster, I use Kubernetes ingress. And there's lots and lots of options for that. I'm personally using the AWS load balancer controller, which is an application load balancer that talks directly to the backend pods for that. So that's how I would do the HTTP layer. I'm not personally doing anything with SMTP, but if I was exposing that, I would use a network load balancer to do the TCP port coming in on that. And then there's lots of other things like the Nginx ingress controller is really popular. The Traffic controller, like there's a ton of options there, but Kubernetes kind of gives you a nice primitive of just defining an ingress, and then whatever the infrastructure team has set up on the cluster should handle that and expose it.
Okay. So as far as I'm just going to try to pop something up here just for those who want some additional reference. I'm just going to switch screens for a second. Something else that can be handy to people is the KumoMTA documentation, and the user guide does have a clustering section. It doesn't go particularly deep into Kubernetes. That's something that that hopefully we add soon enough. Similar architecture concepts, though, as far as how this operates. So TSA daemons are able to be a separate service running on separate nodes, which in a cluster environment can help just to keep that load off of the machine that's running it. You can run more than one of them so that you get fault tolerance as far as that goes. When you create that, just as a reference, in your configuration, you give each node the location of each daemon. They will then forward events to each daemon in the cluster so that those can also then talk back to the individual nodes, let them know what changes to make.
I think I can interject on that real quick too. The reason I like it being separate is because you're cutting down on network chatter. So if you're running the TSA alongside KumoD and you start scaling out Kumo and you have lots and lots of replicas, you have like a full mesh pattern of traffic between those. And I really want to cut down on internode bandwidth as much as possible. So it's nice that you can separate that out, avoid that.
Absolutely. And then, as we learned, as long as it is essentially Redis compatible on protocol, you do have multiple options there as far as which one you implement. I do know that some have been deploying it using like a provided managed Redis implementation off of something like AWS. For event data, for those who used to use Momentum, we did not reintroduce the idea of a clustered log manager simply because back in those days, all of these functionalities pretty much had to be invented from scratch in order to make them work. Here, there's so many available technologies that there's no point in reinventing those wheels anymore. So webhook support is there, AMQP support is there, Kafka is also available for pushing data back to a central place. As far as shared throttles go, we did get into that as well. The reference manual always has the most current information compared to the user guide, which is there just to point you in the right directions. And yeah, so cluster TSA, and also mostly relevant to Kubernetes is spinning up, spinning down. I'm sure you worked with this as well there, but you have the ability to use the liveness API to find out if a node is ready to become part of the cluster and accept messages, or if it's still standing up. And then draining, you have the rebind command, which gives you the ability to push every message or selected messages on your node to another location. Typically, this would be the load balancer. And then using the metrics API on a node, you can find out when that node's ready for shutdown because you'll know when the queues are empty. And I think for you, and as in most cases, this is one of those things where you do it to scale up and down based on your predicted load levels for sending. We did not introduce anything out of the box inside of Kumo to introduce autoscaling because I don't think anyone should trust an automated system they didn't build to do that in an automated fashion, right? So if you want to deploy your own autoscaling, that's something that we leave up to the user. It's not something we expect to introduce because there's a lot of things that can go wrong if you're not doing that specific to your own environment. And most senders have pretty predictable volume levels over the course of a day that I don't know that we ever would really see a need to do that on a granular basis. Blake did ask, how are you handling delivery queues on the individual nodes with auto scaling? So I think the answer is don't do it with auto scaling, at least in my opinion, or if you do, create it yourself. But essentially you're doing this rebind to take all those messages and shift them back to the load balancer. You're also, before you do the rebind, going to tell that node not to be part of the load balancer, or obviously that would be self-defeating, but then you're going to be able to shift that and say rebind, throw it back to the cluster, let the other nodes take it.
Yeah, and in particular in Kubernetes, you'd be relying on lifecycle hooks for the pods to accomplish this. So when it's going to scale the stateful set down, you have the ability to run code before that actually shuts down. So what happens is you start running that check, the pod gets removed from the load balancer, which stops new incoming injections from coming in. And then you're running the rebind command, like saying here, to actually drain your queue back. I would use the load balancer address, so that would get pushed back into nodes that are still up and alive, and then that pod would shut down once the queue is empty. So you'd be using that lifecycle feature to do all those safety checks before you do that. And the other thing I'll mention is with stateful sets in Kubernetes, you have the option of, so like I'm in AWS land, so I have an EBS volume attached directly to that pod for the storage. You have the option of keeping that volume around when the pod shuts down. So if you scale down, you can have that volume stay. And then if you bring that pod back alive, if there was anything on that disk, that'll still be there. Or you can have those volumes go away with the pod. That's up to you. So you have a couple different ways to handle that there. But the lifecycle hook is the key to that.
Right. So just a reminder, like I said, we have, if you go to activities, which is in the bottom right of the window, a little triangle, square, circle, there's a Q&A. Feel free to ask more questions there so we can make sure we cover yours. Any challenges that you ran into while building this out?
When I first was playing with this, like the liveness check endpoint didn't exist yet. Although you guys added that very quickly, so that wasn't a big deal. I think one challenge is you kind of have to implement your own shutdown logic for that lifecycle hook. So you can run the rebind command and then check that metrics endpoint to see when your queue is empty, but you have to actually kind of encode that logic in something that fits your use case. So there's a little bit of a bespoke implementation there. I think most of my challenges were on the proxy layer, running that in a cloud provider, not so much on the Kumo side of things.
There's, yeah, I've seen multiple implementations where one of the bigger challenges is that idea that you're trying to get a large number of IPs into AWS essentially. And doing that, you wind up with a challenge around the idea that how do I get a large enough instance size that gives me enough network interfaces, that gives me enough IPs that I can do that. And there's been multiple cloud SaaS providers that have essentially put everything in AWS except their proxies for endpoints and then put the IPs in something like a colo. There's been recent changes when it comes to working with AWS, where they allow you now, instead of attaching individual IPs to an interface, you can now attach essentially a subnet to that interface instead, and that allows you to address any IP in that.
There's an asterisk on that, though.
There
you can't do that. You can't do that with public IPs or your own public IPs that you would bring to AWS. You can only do that with the private network cider, so it's not super useful for
Oh,
this
so you
case.
can't bring your own IP
Yeah.
with it.
Yeah.
That part I was not informed about. Okay, so something good to know. Again, there is always the answer of put them in a colo, hook your proxies up there, and just make sure that it's got a very fast connection back to AWS, which is pretty easy to find a vendor that does. And it does take away a lot of the challenges around managing, your own IP addresses within AWS.
Yeah, which I did set that up in AWS, so I can talk through that if anybody's interested. I do see another question on Dragonfly.
Yeah.
I guess an asterisk is that I'm like mostly in the exploratory phase with Kumo right now, so I'm not pushing massive workloads through it outside of benchmarking. So I haven't seen Redis be the bottleneck there in any case. And Dragonfly, I know, is architected to take advantage of multiple threads and multiple CPUs compared to a Redis process where you have that single threaded thing going on unless you cluster your deployment. That's been my experience with Dragonfly so far. I am curious to test using like Valkey, for example, which doesn't have that throttle command that comes from the Redis cell module, just to see how well the Lua implementation performs compared to the more lower level module that can be added. If the performance is okay there, I'd probably be more inclined just to use a Valkey cluster from the cloud provider directly.
And just as a reference for those who watch the recording later, the question was, you're using Dragonfly, it looks like it's built for speed, but also single threaded. If you run into write concurrency issues when writing to Redis, did you consider using KeyDB? That's the question after. Daniel's already given the answer, but just for those at home. And then Martin's saying, certainly interested to hear more about managing multiple IPs in AWS. So yeah, happy to have you share that with us.
Yeah, that part was a pain in the butt. It started with a spreadsheet trying to figure out what node type I need, how many IPs I want on each network interface. So AWS lets you associate multiple public IPs with an elastic network interface. And depending on the node type, there's different numbers of network interfaces and IPs you can attach to those nodes. So you have to kind of figure out what's your balance of meeting your bandwidth needs, blast radius. So the more IPs you have on a node, if you need to take that node down for any reason, the bigger the impact's going to be there. There's a lot of juggling you got to do there to sort it out. And then as far as actually handling it, we used a thing called state machines in AWS. So it's basically a state orchestration for a workflow. So we pre-create all the network interfaces. They all have static mappings of private to public IP. That's because in AWS, when you're addressing, like say Kumo wants to send out a specific public IP, you have to actually send to the private IP associated with that, and then AWS handles swapping that public one on the outbound traffic there. So the interfaces all have a static mapping there, so we're not having to go in and babysit those. And then whenever a node launches in the autoscaling group for the proxy nodes, the state machine kicks in, it evaluates how many network interfaces are on the node at a given time, ensures the correct number are there, and that all of those network interfaces are accounted for. And then that happens if you shut down a node and bring a new one up, that workflow would kick in again and heal that. And that workflow is basically, I think there's like 2 or 3 lambdas in there that are doing the logic, and then a couple AWS API calls to get things in a happy state there. But at least the end result is the actual instances for the proxy nodes, they're still just cattle. You can spin them up and tear them down, and they'll get IPs reattached. You don't have to worry about what those are. So it did end up being fairly elegant to run. It was just a pain in the butt to get that implemented.
Well, while we wait, if there's any more questions to come in, I'm going to share something that came to mind because I saw a reference in your repo that not everyone may be aware of. And that's down here in the repo under examples. You're going to find what's called SmartSink Docker. And what it is you had a simple sync script in your repo that was just dev nulling everything that came into the server. What this one does differently than that is you can configure it for probability to say how often do you want messages to bounce, how often do you want them to temp fail, and when you do that, it gives you Tom built this, so it's quite handy, and it's in its own container already. But what it does is it doesn't just look at the fact that there was a 550, whether it should temp or perm. It will actually read out as part of its logic the responses.toml file, which is built from, we had one of our users share with us some extensive logging so we could do some analytics and build up this. And it will actually respond based on actual responses that come back from those providers. We did this because there's needs to work on traffic shaping automation testing, and you have to have essentially, you have to have responses that are realistic to that. So it will go through and it will bounce back based on that reception domain and just essentially what percentages, what probabilities you want to have that happen. And that gives you just the ability to get a bit more realistic load, because the challenge with a sync that goes straight to dev null, it's great for initial testing, but you want that pushback. You want to build up some queue depth so you can realistically know if it's behaving the way it should, and that it's going to, that TSA is going to trigger on some of those events that you want to have occur. This gives you that ability in a container that's right in there as well. So there's some benefit to that for those that are looking to do some testing internally of essentially any MTA. You can fire this up and use it to get a little bit more live fire kind of testing going on with your MTA. So something to be aware of. That's in the regular KumoMTA repo under examples.
It'd be a fun one to build into the demo repo if I find time to.
Yeah, we use it. We use it for our test environment for doing things like Grafana reporting off of Prometheus, so that we can kind of get a realistic view of that. Tom built a demo environment that we use that incorporates that into it, so that people want to see a graph, but they don't want to just see one that goes, across flat. It needs to be up, down, and doing much more realistic behaviors. And that definitely goes a long way to making that happen. Tom's private texting me that he wrote it, but Wes fixed it, which is pretty much important for us. All right, well, we do not have any more questions, but we do not have to use the full hour. So if there's anything else you want to share, that's great. Otherwise, appreciate your time and showing everyone a little bit of how it worked for you.
Yeah, thanks for letting me talk a little bit about what I've been doing with it. And just say again, Kumo is a great piece of software. I've had a lot of fun working with it, and it's a very cool project. It's exciting.
Well, we appreciate it, and I think we will probably figure out a way to get that demo repo that you've built more visible so that others can have a easier chance of finding it. But thank you for your time, and thanks everyone for joining, and we will see you at the next one. Have a good one.